blood, how much more, having been justified, shall we be saved through his life? Not only is this so, but we also rejoice in God through our Lord Jesus Christ, through whom we have now received reconciliation. That's just disturbing, guys. Okay, so everybody, shh. Today we are finishing 71, which is ellipsis. Peter, slash. Okay, so here, I don't care if you sit, I just don't want you to talk, okay? Remember what I told you the other time. How do you tell something is an ellipse as opposed to something is a circle?
It's not a circle. It's divided by something.
Okay, well, I'm not talking about the graph. I'm talking about how do you see from the equation of an ellipse that it is an ellipse and not a circle.
It doesn't have a coefficient of 1.
Go further. It doesn't have a coefficient of 1. There are circles that don't have a coefficient of 1. Okay, you guys? I don't mind if you sit silly, but I don't want you distracted.
Is that on?
Okay. So yes, it is. So, okay, here we go. So now, do you see?
Aren't the same.
The coefficients aren't the same. Thank you very much. The coefficients aren't the same. All right? And that is true over here too. This is an ellipse that's not in its standard form yet. And the coefficients of the two variables are not the same. Okay? So here we go. How did we talk about yesterday? We're going to graph this. Remember when it is in its standard form, this right here is the a squared. And this right here is the b squared. Since this one is bigger than this one, which one is our major axis, x or y?
Well,
X is our major axis, right? Because remember, we take the square root of this, we get a is 5, all right, and we go 1, 2, 3, 4, 5. And then negative 1, 2, 3, 4, 5. Oops, that's 6. Okay, and then what do we do here?
3.
Okay, we take the square root. We go 1, 2, 3, and 1, 2, 3. So we can see that this one is our major axis. The x is our major axis. And we can see that the y is our minor axis.
So that's an ellipse.
That's an
And
ellipse.
that's all you have to do.
Well, there's other things about ellipses, but in this section, that's all you have to do. Okay, so let's look at this ellipse. This ellipse is not yet in standard form. Remember what standard form is. It's got a 1 on the end. Okay, it's equal to 1. So how do I turn this into a standard form of the ellipse?
Everything by 15.
Divide everything by 15. Thank you, Zach. So I'm going to divide everything by 15. Okay, and I have 1/3 x squared plus 2/15 y squared is 1. Is it in standard form yet? No. Okay, you're thinking. What are you saying?
Why didn't you divide the second?
Well, because 2/15 does not reduce.
Where is 7.5?
5. Well, I'm not going to reduce to something that's not a whole. Okay. Now, can I go through? This is not yet in standard form. What is standard form? X over a squared. X squared over a squared plus y squared over b squared equals 1. So I still have a little bit of work to do here. What do I need to do? Don't I need to get this coefficient so it's all in the denominator? Okay, so if I have this is a 3 in the denominator, so it's already there. If I just take this 1 off, isn't this already just an x squared over 3? So that one's fixed because it had a 1 on the top. What about this one? How do I get everything in the denominator?
Y squared over 15 halves.
Okay, it's going to be y squared over, remember I flipped down here 15 halves, so that when it goes up to the top, it would be 2/15.
Or
All right, so I get everything down here. Okay, yes, it's 7.5. Now, what is this? 3 is my a squared. So what is my a?
39.
No, 3 is my a squared. So when the square root of 3 be my a. Okay, and then 7.5 or 15 halves is my 15 halves or 7.5 is my b squared. So what is my B?
Square root
Square
of
root of
7.5.
Square root of 15 halves or square root of 7.5. Shh.
I got you.
Okay? So now, how would I go about graphing that?
Plus or minus square root of 3 to the left. And
Right? Square root of 3 is about 1.7, right?
Yes.
So 1.7. We'll make it bigger, a bigger scale. Okay, we'll make that 1 and that one about 1.7. We'll make this one 1 and about 1.7 because that's about what square root of 3 is. Now, what is going to be the square root of 7.5?
About 2.7.
2 and
2.8.
something.
2.8.
So 1, 2, and a little bit.
2.74.
1, 2, and a little bit. Okay. Now, shh, notice. The vertical axis is the major axis now, isn't it? The vertical axis, because my larger number was under the y squared.
Yes.
My vertical axis is the major axis. Okay, yes, sir.
Why is the circle? Or why is it up weird? It's like an ice cream cone.
Well, because I'm not a very good artist. Okay. All right, now, everybody, shh. You guys are wired. I know it's hard to have math when everybody else is gone, but we're doing it. Everybody look at the next section. We are now on 72, and we're talking about the law of sines. Now, everything that we have done up to this point with trigonometry and sines and cosines and tangents have had to do with right triangles. We have not learned how to do anything with sines and cosines and tangents outside of right triangle situation or being able to form a right triangle situation. Yes, sir, Peter?
What's side of 15?
You need to do that with a formula, which we will teach you. Okay, for the sine of 15, we're going to go to our half angle formulas, and we'll be able to do that. But we're not there yet. So first,
every time.
Yeah. First, we're going to learn.
2, 5, 8.
Okay. Yes.
I want to.
But you need to do it exactly. Okay. And exactly, I can show you how to do that with the half angle formula, which is not very many sections from here. We might actually get there before next one. Okay. So, law of sines is what we're going to use when we don't have a right triangle. Okay. And we've always talked about sines, cosines, and tangents in respect to a right triangle because that's their definition. Remember, when we have a right triangle, the sine of A is what? Opposite over hypotenuse. That's only for right triangles. The cosine is the adjacent over the hypotenuse. Only right triangles have hypotenuses, right? Only right triangles have hypotenuses. So everything we've done before, everything we've done before has had to do with right triangles. What do we do when we don't have a right triangle? Okay? And we go to the law of sines. And the law of sines is very easy to memorize because it's A over the sine of A, B over the sine of B, and C over the sine of C. Where, here's your picture, okay? Here's your A, here's your B, here's your C, but then across from A is side A, and across from B is side B, and across from C is side C. Okay? And whenever you do this, you set up these ratios, and if you can find two parts that you can set up ratios with, you can solve for unknown parts. Okay? But in order to use, look up at the top of lesson 72. David, second slash. You are not paying, you don't even have your book open.
That's because you're teaching.
Oh, open your book. Get your book out. Open your book. Don, can you have your book out? Okay. All right. Lesson 72 says up at the top that you need one side plus two other parts. If you have one side plus two other parts, you can solve using the law of sines, right? Because these up here are the sides. If you have one side and you have two other parts that you can relate, you can use the law of sines. So let's see how the law of sines works with this triangle right here.
Is this the new one?
This is lesson 72. Okay, so we've got this one right here, and we're going to do, we're trying to find X, and we're trying to find A. Okay, so on this one it says find the missing parts. Okay, so we need to find X and we need to find A, our missing parts. So we can set up a relationship because we do have a pair. We need a pair. So we got a pair. We've got a cosine of 33 and a 7. So we can set up this relationship with any two opposite sides. In other words, I can put the 7 over the sine of 23.
14x.
Okay, and then I've got my 10 and my cosine A, or I could do my 13 and my x. Okay, so I'm gonna go ahead and do this one. So sine of 13 and then x. So I've got one unknown that I can solve for. So I'm going to cross multiply, and I'm going to get out my calculator. Get out your calculators. So we're going to have 7 sine of 13 is x sine of 23. So x must be equal to 7 sine 13 over sine 23. Okay, so somebody crank out 7.
Which one is this?
I got it.
Is this 72.1?
Yeah, this is 70.
Be a B.
A B. Oh, they don't have a 13. Oops. 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 Okay. Since that's a B and that's an unknown, I don't want to do that first. Right? Okay. Since that's a B and that's an unknown, I'm going to go with this one that's known, and I'm going to go with this one that I still have a part to. So I'm going to put the 10 on the top, and I'm going to put sine of A on the bottom. Okay. So now when I cross multiply, I get 7 sine of A is 10 sine 23. Okay, so now what is it? Sine of A is going to be 10 sine 23 over 7.
33.9.
Say what?
33.9.
No.
33.
No, it's
No.
0.5582.
Oh my.
Oh, yeah.
.5582.
Oh,
Yes,
sine
0.5582.
I thought you were talking about the angle.
Does everybody concur? 0.5582? Okay. Now what are we going to do? If this is the sine of A, the inverse sine, okay,
33.9.
is what?
33.9.
33.93. So we take the inverse sine of both sides and we get 33.93. So our A, now, remember, you have got an ambiguous situation when you're talking about sines. However, this is very obviously acute. All right? It's obviously acute in the picture. So we're going to take the acute angle. What is the other angle that would have the same sign? Okay, if this is 30 on this side, right, then wouldn't the same angle on this side have the same sign, right? They'd have the same sign. However, that would be a very obtuse angle. Okay, and it would be impossible because we already know that we have other angles in here. We can only have 180 altogether, and this is very obviously acute. So we're going to go with the 33.93. I have a picture of what's going on. So I know that that's not an obtuse angle. It would not work. Okay, so I'm going to go with the 33.93 is right here. 33.93. Okay, so now that I have this angle and I have this angle, can I figure out what that angle is just by subtraction?
Yep.
What's my rule? 180 rule, right? So I'm going to take 180 minus the sum of the other two. So what is this other angle?
123.07.
123.07. Okay, so now that I have that angle, can I find this side?
C.
All right, so now I set up another proportion, and this one's going to be what? If I'm trying to find the x, I want this one to be one of them. So 123.07 over, no, that's my sign, excuse me, x over, I told you I was a little dyslexic, 123.07, so I put the side over the sine of the same angle, right? And then I can go back to, either I could go back to my original one. I don't have to go to my new one. I can always go back to my original one and take 7 over sine of 23. So I set up another relationship to be able to solve. So I get x sine 23 is 7 sine 123.07, and x is equal to 7 sine 123.07 divided by sine 23. Okay, so when we crank this out,
15.01.
the next is 15.01.
316962.
Okay, so, very good. Now look at that little note down at the bottom of that example. It says, we note that there is no ambiguity when the law of signs is used to solve for a missing side. All right, so when we're solving for a missing side, we don't have to worry about the ambiguity. But when we're solving for a missing angle, we can have ambiguity in the situation if we don't have a picture and if an obtuse angle would even be possible. Okay, in this case, the obtuse angle would not have even been possible because the other angle was already 23. Okay, so if we had the obtuse angle, you would only have 33 degrees left on the other side minus the 23 degrees. That means that would have to be a 10-degree angle, and it is obviously obtuse. Okay, so we didn't have any ambiguity there because we had a picture of the situation, and it wasn't going to work. Okay, another thing that you can tell that you should use in your analysis, since this side is 10 and this side is 7, remember that the larger angle opens up to the larger side. All right, so doesn't it make sense conceptually that if this is a 23 and that was given across from the 7, that the one that's across from the 10 should be a little bit more, a little bit wider angle, okay? And this one, in the picture, at least looks like it's the largest side, okay? And it is opposite the largest angle, all right? So you should be able to determine those. Okay, we're going to do another example here.